Hello, section 6.2, radicals and rational exponents. We spent a good portion of chapter 6 so far, the beginning, simplifying square roots. Okay, remember a square root symbol looks like that. Okay, and what the square root does is it gets back to the original. The square root of 16 is equal to 4 because 4 to the second is 16. Okay, so we're dealing with this squared idea. Well, we have other roots besides square roots, meaning we don't always take things to the second power. We can take things to the third power, to the fourth power, to the fifth power. So we call those nth. So we can actually take the root of those. So we can have what we call the nth root of a. So instead of having a square root, okay, we could have a third root, and it would look like we still use the radical symbol, but we put a little bitty 3 in here to denote that we're taking the third root of something. And so what we're looking for is we're looking for something, some number to the third power is some other number. We're looking for what is the root of that third power. Okay, I think it'll make sense once we do a few more examples. So here we have the third root. We have that same radical symbol. So the radical symbol is this guy. The number in here is what we call the index. The index of that radical. In a square root, like up here in our square root, the index is considered a 2. It means we're dealing to the second power. But we don't, again, it's a little bitty number inside that little crook, that little arm, inside the crook of the arm. We put a little bitty number in there. But since we do square roots so often, we normally omit that 2, and it's just known that if there's no number there, that it's 2. So the index is the number inside there. The index is the power or the exponent that you are wanting to get the root of. Okay, so the index is that little number in there. So that little number in there is the index. Okay, so for example, I know that 2 to the third power is 8, because that's 2 times 2 times 2. So then the third root of 8 is 2, since 2 to the third is 8. Okay. We don't know our cube roots and our fourth roots as well as our square roots, so we're not going to create a list of them. We'll just have to use our calculator and kind of list them out as we need them and practice taking things to certain powers. Okay. All right. So we talk about our nth root. So we can have a third root, which we tend to call a cube root. We could also have a fourth root. A fourth root. Okay, so let's say the fourth root of 64. Okay, or the fourth root of 81 is 3, because 3 to the fourth is equal to 81. Okay, so they relate to, it's dealing with, this index is telling us what exponent that we use are we looking at. Okay. Nth roots can also be written as exponents. Okay, it's kind of this neat thing where instead of having to use this radical symbol all the time, this radical symbol, instead we can write it as a fraction exponent. Nth roots can be written as fraction. Oh, I put that in the wrong spot. Can be written as fraction exponents. What I mean by that, okay, is if I have the square root of 4, the index in here is a 2. This is the same as taking 4 to the 1/2 power. This index becomes the denominator in my fraction here. And the reason for that is really from our rule of exponents, we know that 2 to the second power is 4. Okay, so then if I take that to the 1/2 power, my rule from section 6.1 tells me I multiply these things. 2 to the 1/2 is 1, so that just gives me 2 to the 1. Because we know that 2 to the second is 4, and the square root of 4 is 2. Okay, so really it's how we undo those square roots and how those square roots relate to that exponent that makes this fractional rule, a fractional exponent. Okay. Okay, so if we're taking an even root, if my index is even, if the index is even compared to the index being odd, we kind of have to keep track of whether that index is even or it's odd, because if it's even, if the index is even, for example, I'm taking 2 to the 4th power. Sorry, negative 2 to the 4th power. I'm multiplying an even number of negative 2's. So what ends up happening to those negatives, a negative times a negative is positive, a negative times a negative is positive, I get a positive. Okay, so like the fourth root of 16 is equal to, negative 2 to the 4th is the same as just straight up 2 to the 4th. Okay. Because if I multiply just 4 2 times, I still get that same thing. In both these cases, we get a positive 2 times 2 times 2 times 2, 16. Because there's an even number of negatives. So if your index is even, for example, if I'm taking the 4th root of 16, I could get out a positive 2, or I could get out a negative 2. So if that index is even, we have to realize that I could get both things out. So it could be a 2 or it could be a negative 2, because negative 2 to the 4th is 16, and because of my negative 2 to the 4th is 16, and my 2 to the 4th is 16. Okay, so the 4th root of 16 could be 2, could be negative 2. So how we write that is mathematics. Again, we like to shorthand things. It was we would write this as positive or negative 2. This is just a shorthand way of saying, well, it could be positive 2 or it could be negative 2. But this issue only comes up with an even index. If my index is odd, okay, over here odd, negative 2 to the 3rd, well, that would be negative 2 times negative 2 times negative 2, which is negative 8. Straight up 2 to the 3rd is 2 times 2 times 2, which is 8. So if I have the cube root of 8, I know I'm only going to get out the positive 2. Because 2 to the 3rd is 8. Now if I have the cube root of negative 8, I'd get negative 2. Because negative 2 to the 3rd is negative 8. Okay. But if my index is even, like this even one over here, word of caution, if I'm taking the 4th root of negative 16, there's no way I can multiply a number times itself 4 times, like in this case negative 2 4 times, and get a negative 16. So in this case, we would say this is undefined. You can't actually do it. There's no real root. Okay, so we say there it's undefined. You can't take an even index of a negative number. You can't take an even index of a negative number. Okay, so here, find the indicated real nth roots of A. So here I'm looking for the 3rd root of negative 27. So looking what number times itself 3 times, so looking what number times itself 3 times, times, is going to give me a negative 27. Well, I know it's not 2, because up here we did 2 to the 3rd is 8. So I'm going to maybe try 3, negative 3, negative 3, negative 3. That gives me 9 times negative 3 is 27. Yep, so the 3rd root of negative 27 is negative 3. My index here is odd, so I don't have to worry about the plus or minus here. I'm just straight up negative 3. Okay. Now what about in this case, this next one, the 4th root of 16? We kind of already did that one up here. I could get out a positive 2, or I could get out a negative 2. So we would write our answer as plus or minus 2. Okay. All right, next one. Okay, here we have the third root of negative 8. So this is asking me what number times itself. 3 times is going to give me a negative 8. Well, I want a negative 8. Index is odd, so it's going to be, well, we decided up here that the cube root of 8 was 2, so let's try negative 2. Yep, negative 2 times negative 2 times negative 2 gets me negative 8. Yep, so the third root of negative 8 is negative 2. Okay. All right, what about this next one? We have the negative of the third root of 8. Order of operations, we have to do this guy first. So this negative is just kind of floating out front here. You can think of it as negative 1 times that. So I would take the third root of 8, which we know from previous problem, the third root of 8 is 2. Oh, sorry. Oh, no. Okay, so the third root of 8 is 2. So I've got the negative of the third root of 8, so that gives me negative 2. Again, index is odd. I don't have to worry about it. Okay. Ooh, now we're dealing with this fractional idea. What the heck is this doing? I have 16 to the 1/4. This 1/4 tells me I'm taking the fourth root of 16. So I have the fourth root of 16. Okay. So since I have the fourth root of 16, this tells me what number times itself 4 times is positive 16. Okay. So I believe it's 2. So we end up with 2. Index is even, so we probably want plus or minus 2. The textbook might omit the negative 2 in this case, just because, I don't know. Sorry. Well, plus or minus 2. Either one of those will work in this case. Okay. The next one we have, this is the same problem, but now we have a 16 in there, a negative 16 in there. What number times itself 4 times will give me a negative 16? Well, since my index is even, this number in here is negative, I can't do it. So we would say this is undefined. Okay, so we would say this is not a real number in this case. Okay, so when we look at that undefined, we say it's not real. We'll talk about what kind of numbers are not real in a minute. Well, not in a minute. Algebra 2.